Welcome to lesson 3.1, where we start our discussion on similarity. Now, in the last unit, you learned about congruence, and that's where two shapes are the same size and shape. Similar triangles and similar shapes, they're the same shape, but they're different sizes. Also put, they have the same angles, but different side lengths. All right? So let's talk about this. Okay, let's put this in writing. So triangles are similar, and this is the same for shapes, but triangles are similar if they are the same shape, okay, but a different size. Okay? Why is it doing that? Okay? So if you look at our two examples here, these two triangles over here, right, they are the same shape. They're both isosceles triangles, and they are just different sizes. So this is a good example of similar shapes. All right? Now if you look here, these two triangles, while they're both triangles, they are not the same shape. This one's a scalene, this one's isosceles. You know, they just wouldn't map onto each other with a dilation. See what I just did right there? But while they are the different sizes, they are not the same shape, so they're not similar. So different sizes, not the same shape. So this is not similar. All right? They're just going to look like blown up versions of each other. Similar. Okay? So this one gets both checks. All right? So this one just looks like a dilation. See the connection there? This one, not a dilation. Yes, there is connection. We'll talk more about it in class. Now there's two major properties of similarity you got to know. These are major. Do not forget them, okay? If triangles are similar, we know two major facts. One, the corresponding angles are congruent. All right? I want to say this is the third time I record this video because I keep spelling corresponding wrong. Man. So we know all the corresponding angles in these two triangles are congruent. All right? So for example, since O and A correspond, then we know that they are congruent in both triangles. So if this was, let's say, 30 degrees, this would also be a 30-degree angle. All right? So angle O is congruent to angle A. Another way to know which angles correspond is the order of these letters matter. So triangle ROB is similar to triangle FAT. See this little thing right here? That means similar to. We'll be using that a lot. All right? So since they're similar, I know that O and A are going to be congruent. The order of these are matter. Remember how I keep telling you the order that you put these letters in matters? That's because it tells you what's congruent. O is congruent to A. Now also using this, I could also say R is congruent to F. See how those are both the first letter? So R is congruent to F. Okay, and we'll write that over here. Did I put an A over here? Ugh, God, what is going on? That's an A. O is congruent to A. R is congruent to F. And then finally, since B and T are our last letters, so we know B is congruent to T. All right? So angle B is congruent to angle T. So that's the first major thing about similar triangles. The angles are always the same. They're always exactly the same. If this is 30, this is 30. If this is 50, this is 50. And if this is 100, this is 100. The angles are always going to be the same. Just like in a dilation. See the connection there? See? It's there. All right. Now we also know that the ratio of the corresponding, I'm going to spell it right this time, corresponding sides is the same. So what does that mean? Well, that means the ratios between all of the sides from the bigger triangle and the smaller triangle are going to be the same. All right, and specifically the corresponding sides. So, how would I do that? Oh, I'm going to erase this for a second. Now here, if you look here, OB corresponds to AT, right? And the ratio of OB to AT is 12 to 6. Okay? Now the way I was able to figure out that they corresponded to each other is because OB and AT are both the last two letters. It also looks that way, but you could always use it by the order. So since the last two are OB and AT, I know those correspond. So the ratio of 12 to 6 is 2. Now the ratio of all the sides are going to be the same. So if you look here, the ratio of RB to FT is 8 to 4. So RB is here, FT is here. Let's put that in. The ratio of RB to FT is 8 to 4. And that ratio, 8 to 4, is 2. Okay? And now once again, you could check to see if you're doing this right because RB and FT are also in the same position. And then finally, we have OR, the ratio of OR to AF. Now once again, that ratio is 10 to 5. Okay? Got these numbers right here. And the ratio of 10 to 5 is 2. Alright? And once again, you'll see that RO and FA are also in the same position. So the ratio of all the sides will always be the same. Okay? Now this ratio that's the same is called the ratio of similitude. Okay? The ratio between these sides, this constant ratio that we have is called the ratio of similitude. And it's the same for all of them. Okay? So that's the two big facts with similar triangles. The angles are all congruent. The angles will always be the same, just like within dilation. And the ratio of all the sides is the same. Okay? Might not always be 2, but it'll always be the same. So let's move on. Now we can use this fact that the ratios are all the same, all right, to figure out what different side lengths are. And I'll show you how to do that. We're going to set up proportions here. So let's look at this question here. Triangle BIG is similar to triangle LUV. Okay, these two triangles are similar. What is the length of UV? Well, the way you do it is this. First, you're going to do this. You're going to put an X where you want to solve it. So we want to find out what UV is. Let's put an X there. Now, what we're going to do is set up a ratio. All right, the ratio is this. We're going to find a pair of matching side lengths. So if you see here, I have BG and LV, which correspond to each other. If you want to check it, BG is the first and last. LV is the first and last. So those two correspond to each other. I'm going to set my ratio. That's 10 is to 5. Okay? Now, what I'm going to do is set up my next ratio, and I'm going to say, what does X correspond to? All right, that's UV. And UV corresponds to IG. All right. Now, I'm going to set up my next ratio. So since IG and UV correspond, and once again you can check that by looking at the order of the letters, IG and UV, let's set up our ratio. So that's going to be 14, all right, over X. All right. And now that we set up our ratio, we can just cross multiply to solve. So we cross multiply, bing bang, we get 10x is equal to 70. Divide both sides by 10, and we get x is equal to 7. All right, so to answer our question, UV, the length of that is 7. Now I want to make a big important point here. Whenever you're setting up your ratios, all right, the same triangle has to go on top and the same triangle needs to go on the bottom. To show you what I mean is this. On the top, we both used our bigger triangle, right? 10 and 14 were from the big triangle. And on the bottom, we put the small triangle. Now, do you always have to put big on top and small on the bottom? No, we'll do it the other way next time, but the same ones have to go on top. So it has to be big, big on top and small, small on the bottom. Or you can do small, small, big, big, but they always have to be the same, okay? So big, big on top, small, small on bottom. Let's try the next one, all right? Triangle ABC is similar to triangle DEF. Find the length of CB if AC is 12, DF is 9, and FE is 14. So we know the triangles are similar because that's what that little symbol means. That means similar. And then we have all these side lengths. Well, we're trying to find what CB is, so let's put an X there. We always put an X for what we want to find. And we know that AC is 12, DF is 9, and FE is 14. Okay? So what we're going to do is set up a ratio to solve for X. So let's find a pair of corresponding sides. I know that AC, all right, this length right here, all right, and it's kind of hard to see what it corresponds to here, right? It's kind of hard to figure that out. Does this correspond to 9 or 14? I can't really tell. Well, if you look here, we could, if A and C are the first and last letter, we can do that here too. That's D and F. Okay, so AC corresponds to DF. So let's set up that ratio. This time I'm going to do the smaller triangle on top. So that's 9 over 12. Okay, so I put the small on top, and then on here I put the big triangle. Okay, so my next ratio is going to be, well, 14 and X. So that's FE and BC. See how those correspond? Those are our corresponding sides. So let's set up the same ratio. Now remember, we're putting our smaller triangle on top, so we're going to put 14 on the top because that's from our smaller triangle, and smaller triangles going on top, and X on the bottom. Alright, we just cross multiply these guys and we get 9X is equal to, I can do this in my head, 168. Divide both sides by 9, and X is equal to, oh man, I can't do that in my head. Hold on, I'll take out my calculator, which is 18.666, and that goes on forever, so we'll just put the bar. Okay? Is it a decimal? Yes. Am I cool with that? Yeah, I can handle decimals. We're in 10th grade now. We're okay with it. So CB is equal to 18.6666 bar. Okay? So the big thing is, I'm going to tell you, the hardest thing here is figuring out how to set up your ratios. And remember, the same triangle always has to either go on the top and bottom. So the small triangle always went on the top here, and the big triangle went on the bottom. It doesn't matter which way you do it as long as you're consistent. Okay? You also have to figure out the corresponding angle, the sides. And if you do that, you're going to be good money in this lesson. Now here's the last one, and this is I'm making a huge important point out of, right? I'll show you what I'm talking about. So in this example, we know that triangle XWV, which is this smaller triangle, is similar to XYZ, which is the bigger triangle. Okay? The next information it gives us is that XW is 4, WY is 8, and WV is 5. All right? It's asking us for the length of YZ. Now to solve this question, I'm going to tell you this. Whenever you have two triangles that are on top of each other, you need to redraw it separately. I'm not kidding with you. I want to see this every time you're doing it. Okay? You need to separate these triangles. So you're going to separate the smaller triangle and the bigger triangle. You're going to redraw it. You got to do it. You got to do it. Don't mess around with this. The smaller triangle is WXV, and the bigger triangle is YXZ. Okay, I'm just using these letters here. Okay, now the next part is you got to refill in what the lengths of everything is. So in this one, XW is 4, WV is 5. All right, YZ is X, it's what we're looking for. And if you look over here, we want to find the length of XY, which is this whole length. So what's the length of this whole thing? Well, you guessed it. You got to add these two parts together, because if this is 4 and this is 8, we're going to add them together to get 12. Okay, to get the whole length. We had to add those together. And now we can set up our ratios. So in this one, if I'm solving for x, I know that xy corresponds to xw. All right, and if you see that, xy corresponds to xw. So that's 12 is to 4. So I'm putting my bigger triangle on top. All right, and it might help if you label. I'm putting my big on top. That's a little note to yourself. And I'm putting the smaller triangle on the bottom. Okay, and then my next set of corresponding sides is YZ and WV. YZ and WV. Okay, so the bigger triangle goes on top. X is from the bigger triangle, and the smaller triangle is 5. Now we just cross multiply to solve. 12. All right, you might remember this. 12 times 5 is 60. 4 times x is 4x. All right, to solve this, we're going to just divide both sides by 4, and we get x is equal to 15. So if it asks us what yz is, that is 15. Yz is equal to 15. Bing, bang, boom. Now that makes sense too, right? I just want to clarify. These answers should always make sense. You always want to make sure at the end that you're like that these answers are like not coming out of nowhere. If you look at the ratio of 4 to 12, you know that it's 3 times as big, right? So you could say that if this is 5, I know it's going to be 3 times as big here, so it has to be 15, right? 4 to 12 is 3 times as big, 5 to 15 is 3 times as big. The ratios will always be the same, just like in a dilation. All right, guys, that's it for this lesson. Remember, never, ever, ever pick your nose and eat it in front of anyone, because that's gross, but you could do it alone. Beans.